So I can't say good morning anymore because now it's the afternoon. So good afternoon. Welcome back. Hope you had a relaxing break. Today we're going to pick up in section 4.5. I have 3 goals that I want to accomplish today. Goal number 1 is I want to graph the tangent function. Tangent of x function. It's awesome times. It's good math all the way through and through. Okay? Second thing, I want to graph the secant function. Okay? And then the third thing is I want to hand back some old, I got a pile of tests and quizzes and all that fun stuff to hand back to you. Okay? Right? So you don't need special graph paper at all for these graphs. We're just going to kind of sketch them on your paper. But I would like you to, at some point in time, put down the function, y equals tangent of x, and then this set of axes. And we're actually going to, go from negative 2 pi almost, that's close enough, to 2 pi. We could go further, but we'll just keep it in that range right now. Okay? You will need out your own unit circles because we will be referencing them numerous times today. Okay? So, my first question to you is this. Okay? What is tangent? What do you got, sir? Sine over cosine. Do we all agree with sine over cosine? Tangent is sine over cosine. Okay? So this is the sine of x over the cosine of x. Okay? Which on the unit circle is what? What is tangent on my unit circle? Or how do I find the tangent of different thetas? How do I find tangent on the unit circle? That's right triangle trick. What do you got? Y over x. Do we agree that since sine is y and cosine is x, this is really like y over x? Okay. So based off of that, and the fact that I want to graph this, I'm going to pull this down just a smudge. Down to there. Oops, got to bring these down too. All right. Okay. I'm going to group those. I'm not going to do that. Okay. All right. So we got that. All right. So let's look now. Let's figure out what the tangent of, let's say, 0 is. Put those all in blue. Oops. We'll stay in radians, not degrees. So what is the tangent at 0 on the unit circle? Y over x. At 0. We got 0. Because it's 0 over 1, right? So that's going to be 0 over 1, which is going to be 0. So it goes through, tangent goes through the origin. Somebody's got the squeaky desk. Express, yeah. It happens. You got seats open up here if you want to get out of the squeaks. Okay. All right. Where else is tangent equal to 0? At 2 pi. Because 0 and 2 pi are the exact same thing. Where else would tangent be equal to 0? Negative 2 pi. Because if I go counterclockwise around the circle, 2 pi, I'm here, or if I go clockwise around the circle, the negative direction around it, I'm still there. Anywhere else? What do you answer? Why pi? Okay. Anywhere else? Negative pi. Because again, if I go in the positive pi direction, if I go up counterclockwise to pi, that's the same as going in the negative direction down counterclockwise to pi. So the tangent of negative pi is also 0. Okay, getting closer. Like it so far. Yeah. Now, so we got the pi's. We're good there. Let's try these middle ones, these pi over 2's. Let's try those. Okay. What is the tangent at pi over 2? Tangent at pi over 2 is what? Undefined. Why is it undefined? Because it's 1 divided by 0. Roll. How do I graph undefined? Not a whole. That's if something cancels out. That's if something that divides by 0 cancels out. That makes a whole. But you're on the right track. You're in the right Algebra 2 unit. No, that's a whole. What kind of dashed line? Well, there's lots of different kinds of dashed lines. Vertical one? What do we call those? Kind of asymptotes. Vertical asymptotes. Yep. Vertical asymptotes go on dashed onto our graph. Okay? And we just happen to have one at pi over 2. Oops, I missed. What about at 3 pi over 2? What's the tangent at 3 pi over 2? Why? So that would also be a vertical asymptote then, correct? Yep. Didn't miss that time. Now, let's do some fun unit circle math. Pi over 2 is the same as what? No. Negative 3 pi over 2. With me on that? Because if I go a positive pi over 2 or a negative 3 pi over 2, I'm at the exact same spot. So at negative 3 pi over 2, there would also be a vertical asymptote. 3 pi over 2, oops, wrong color. 3 pi over 2 is the same as what? That one's negative pi over 2. Ooh, I missed that one too. So we're getting closer. We just got to figure out now what goes in those sections, right? Okay. So let's figure out something along the line, somewhere in between. So what would be halfway in between pi over 2 and 0? Pi over 4. What is the tangent at pi over 4? Agree? Okay. So at pi over 4, we are at 1. Agree? Okay. Getting closer. Right? Do we have something in between pi over 4 and pi over 2? Do we have a point on our unit circle in between there? Pi over 3, right? Okay. So what is the tangent at pi over 3? Tangent at pi over 3. Square root of 3, which is what? Approximately, how much is the square root of 3? Don't worry, I'll do it. Anybody else get it yet? Press, what do you got? You got a calculator out? 1.732. Look alive. You're welcome. Okay, so that's 1.732. That's kind of up in there, right? So what do you think is going on? In there? Anything yet? Okay, let's try some more. Let's go this side of 0 now. Let's go negative pi over 4. What is the tangent at negative pi over 4?
-1.
Because it's negative root 2 over 2 divided by root 2 over 2.
I think so.
Yeah, no, you're right. I'm not doubting you. I'm just making sure everybody else knows. It's kind of what I got to do. Okay. So that one is down here. What about the tangent at negative pi over 3? Negative square root of 3, because now it's going to be negative root 3 over 2 over 1/2, which is negative square root of 3, which is negative 1.732. So I think we can say with some fairly good authority that this section or this sector of this graph looks like that. Would you agree with me? Now, knowing what you know about tangent and the unit circle, okay? So if I am in quadrant number 1, the tangent values are going to be the same as what other quadrant? As what? 3. So quadrant 1 is the same as quadrant 3. Well, this right here from 0 to pi over 2, this right here, that's quadrant number 1, correct? Right? Quadrant number 3 runs from pi to what? 3 pi over 2. So this is quadrant number 3. Quadrant number 3 also runs from negative pi over 2 to negative pi. So this is also quadrant number 1 or quadrant number 3. Quadrant number 1 also runs from negative 3 pi over 2 to negative 2 pi. So this is negative quadrant number 1. Now I'm going to remove all my squiggles. Sure I will. There we go. Okay. So all of those sections should look the same. Oops, did that wrong. Went parabolic instead of. There, that looks better. This is which quadrant? Which quadrant is that? Which one? It's quadrant 4. Because quadrant 4 runs from 0 to negative pi over 2. Okay? So that means all those sides, this side here, that one, this side here, and this one right here, are all those because that's quadrants 2 and 4. So all of those should look like that. And if we had to go out farther along the horizontal axes, we would just keep repeating that process. Okay? And they would all look like that. You would have vertical asymptotes at all the over 2's, and so on and so forth. Okay? Handle? Now your homework for tonight, for everyone, is that you have to graph cotangent and cosecant. Okay? And it's due on Friday for everyone. Okay? So what I want you to do now is I want you to start on a separate sheet of paper, because we're going to fill the bottom up of that paper with secant. But on a blank sheet of paper, I want you to start graphing cotangent while I pass the stuff out. Okay? Alright, so we're going to pick up, so just tap the brakes on that one where you are right now, because you'll do rest of that you can do tonight or tomorrow or whatever. I want to do secant now. Okay? Alright? So secant is what? What is secant?
The opposite of cosine.
The opposite, so 1 over cosine, the reciprocal of cosine, because opposite to me means negative positive. Reciprocal of cosine. Okay, so that's 1 over the cosine, which on the unit circle is what? What am I talking about on the unit circle then? 1 over x. Okay, so it's 1 over x on the unit circle. I should put that on the unit circle part 2. let's start at 0. Actually, let's put our scale in here. We want to go from negative 2 pi to positive 2 pi. Scientifical measuring going on here. Hook 'em horns. So what is the secant of 0? One, because it's 1 over 1, right? Okay. Which means the secant of 2 pi is what? 1. Which means the secant of negative 2 pi is 1. Same for 4 pi and negative 4 pi. 6 pi and negative 6 pi. Right? See how that's working? Every lap, it goes back to 1. Okay. What is the secant of pi? Why negative 1? Because now it's 1 divided by negative 1, which is negative 1. I feel like that's a little high. Oh, that's pretty close. Or fairly close, I should say. That would be the same as what? Negative pi. What's another one? Think outside the 2 pi range. Pi, negative pi. Not negative 3 pi over 2. Where else would we have, where else is secant equal to negative 1? Pi, negative pi, 3 pi, 5 pi, negative 3 pi, negative 5 pi, the odd pi's, right? Okay. So it's positive 1 at the even pi's, it's negative 1 at the odd pi's. Okay. So we got a little W action going on there now. Okay. Let's go to the halves then. pi over 2. What is the secant at pi over 2? 1 undefined. 1 divided by 0, right? The cosine at pi over 2 is 0, so this is 1 over 0, which is undefined. Agree? Okay. So that's going to be the same as, so pi over 2 would be like what? What? Negative 3 pi over 2. Need some more. Go outside our range. 5 pi over 2. Negative what? Negative negative 7 pi over 2. 9 pi over 2. Right? Okay, just keep adding 2 pi, subtracting 2 pi to find all those. Okay, so that's going to give me those. What about the secant at 3 pi over 2? One over 0 again, right? So what is 3 pi over 2 the same as? Negative pi over 2. Need some more. 7 pi over 2. Negative 9 pi over 2. Negative 5 pi over 2. And so on and so forth. Okay? So we still have vertical asymptotes. Two for 4. Throw it there, right? Okay. Now what do you want to go to? Pi over 4. What is the secant at pi over 4? One over what? What's the cosine at pi over 4? Square root of 2 over 2. Dividing by a fraction, I do what with the fraction? Flip it and multiply it, right? Well, when I flip it and multiply it, I'm multiplying by 1, so I just need to flip that bottom one. Gets me that. Anybody know what 2 divided by the square root of 2 is? Square root of 2. I would rationalize that denominator. I just get the square root of 2, which is 1.414. Okay? So that is up here. Now, do you think the pattern's going to flow just like tangent? In that over here, over there, that's really, what would that be, 9 pi over 4? Is that the same as pi over 4? Yeah, because it's just a whole other, it's another lap around, right? Go around one whole time, and then go another one, so you went around 2 pi, plus another pi over 4 is 9 pi over 4. Okay. So this what else was it the same as? Negative 7 pi over 4. Which is right there. What is the secant at negative pi over 4? Secant, negative pi over 4. Square root of 2 again, right? Because it's going to be the same, because the cosine's the same. And this, negative pi over 4, is the same as what? Negative pi over 4 is the same as what? 7 pi over 4? Negative 9 pi over 4? And so on and so forth, right? So that would be here, here, and there. Fairly good inkling that in those sections, it's going to look like this. Would you agree? Fairly good inkling that in the two other sections that it's going to go down, right? Let's verify. Okay. So we're talking in here, this is 3 pi over 4, correct? And what would that one be? 5 pi over 4? So that's going to be 1 over negative square root 2 over 2, which is going to be negative square root of 2. And that one's the same as negative 5 pi over 4. 3 pi, 11 pi over 4, and so on and so forth. Negative 13 pi over 4. And the secant at 5 pi over 4 is going to be the same. But this is, oops, I missed my arrow. What's that one the same as? So 5, so that's going to be negative 3 pi over 4, negative 11 pi over 4, and so on and so forth. So those are negative ones, or excuse me, negative root 2 over 2, and negative root 2 over 2. So that one looks like that. Okay. Again, your homework for everyone in class is to graph or sketch cotangent and cosecant on the interval negative 2 pi to positive 2 pi. And we are going to collect those on Friday for everyone. Okay?